This is Britt Caswell with another example video. In today's video, I'm covering example 3 from lesson 8-3 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to compare properties of quadratic functions. Alrighty, so it says the trajectory of the water from fountain A is represented by a function in standard form, while the trajectory of water B from fountain B is represented by a table of values. Alright, so here's A and here's B. Compare the vertex of each function. Which trajectory reaches a greater height in feet? Okay, so we are going to find the vertex on each of these and compare those y values to find which one has the greater maximum. Now for fountain A, in order to find our vertex, the first thing we have to do is we have to identify our axis of symmetry. Alright, I'm going to use the formula x equals negative b over 2a to do so. And then once I have found that x value for my axis of symmetry, then I'm going to take that value and plug it in as the x value for my vertex and evaluate my function at that value. Alright, so that's kind of the name of the game here for A. So let's get into it. So my first thing, I need to identify my a, b, and c for my function. So this negative here in front of the x squared is like negative 1. So that's my a. My b is 2 and my c is 8. So for my axis of symmetry, I have negative b, so negative 2, over 2 times a, which is negative 1. So I'm looking at x equals negative 2 over negative 2, which means that our x value here for our axis of symmetry is 1. And so I'm going to take that 1 and plug it in everywhere where I see an x in my function. And that'll help me to find my y value of my vertex. So for this first term, 1 squared is 1, and then it has a negative in front of it, so I get negative 1. 2 times 1 is 2, and then that 8 comes down. And so now I just have to collect my like terms, and I get that this one has a maximum height of 9. So now let's look at fountain B. So remember that quadratics are symmetrical. So what I can do is I can kind of like pair together points that have the same y value, and eventually within each set you'll find one that doesn't have like a pair to it, and that one that doesn't have a pair to it is going to end up being your vertex. So here, like my 5s go together, so these guys are reflected. And then when I look here, I have a set of 8s that go together, so those ones are being reflected. And then you could see that negative 410, it doesn't have a pair. So this would be the vertex of my function. So if I'm doing a comparison, fountain A went up 9 feet, and fountain B went up 10 feet. Okay, so my answer to this would be fountain B. It went 10 feet instead of 9. Alright, so we're going to do that same process for the triad. Alright, I'm going to find the axis of symmetry and vertex of f of x, and then I'm going to compare it to the graph of g of x. Alright. So first I need to find my axis of symmetry. So I'm identifying my a, b, and c values. So for my axis of symmetry, I have negative b, so negative 0.6 over 2 times a, which is negative 0.3. Whew, y'all, that's a lot of negativity in my life, isn't it? Let's get rid of some of it. So a negative 0.6 is a positive 0.6. And 2 times negative 0.3 is negative 0.6. So my axis of symmetry for f of x is at -1. Alright, so now I'm going to do my vertex. I'm going to take that -1 that I got for x, and I'm going to solve for y. Alright, so I'm doing f of -1. Now this takes me a minute, right, because there's a lot of decimals on here. Yuck. Alrighty, so -1 squared is a +1. Times a -0.3 is -0.3. -0.6 times -1 is a +0.6. And then that -0.2 comes down. And then we could collect those like terms. So -0.3 and -0.2 makes -0.5. So 0.6 minus 0.5 gives me 0.1. Alright, so this vertex is at -1.1. But take a look at function g. This one has a vertex that's lying right there on the axis. So this is at 3, 0. So if I'm trying to find which one has the greater maximum, I'm comparing their y values. So I'm comparing 0.1 to 0. So on this, I would say f of x has a greater maximum, because 0.1 is bigger than 0. So there we have it, guys. That is comparing properties of quadratic functions. Until next time.